Hello and welcome to the fifth session of Computer Networks from Scratch. Now in this session, we shall be talking about IPv6 in detail with special focus on practical implementations. Now this integrated approach is very useful for those who are appearing for GATE examination and for engineering students. No doubt important for anyone seeking knowledge. And in case if you have not subscribed, kindly subscribe and press the bell icon for immediate updates. Now that's for today's question. What's the significance of all these icons? Well, you are right, they are USB icons, but is there any technical difference in them? Alright, we'll talk about it by the end of this session. Now IPv4 has been very important part of the growth of TCP/IP and the internet. In fact, IPv4 is a core protocol that defines addressing and routing, but there are some limitations to it, and that's the reason there was a need of IPv6. Now IPv6, it defines the same general function as IPv4, but with different method of implementation. It's 128 bits address size. Routing protocols, they are quite different, and routers need to be configured differently so that they match with the IPv6 protocols. But one final verdict is, positively, it's a great pleasure to learn IPv6. These are the aspects of IPv6 which we shall be discussing. We'll be talking about hexadecimal system very quickly. Then we'll see that what exactly is the need of IPv6. Why is it needed though IPv4 is available? Then there would be some foundation about IPv6. And then we shall talk about Big Boss in IPv6 zone. Big Boss means those authorities with rights to distribute and handle IPv6 addresses. And then we shall talk about types of IPv6 along with its practical implementation. So let's start. Now this is hexadecimal system, and we know that in hexadecimal system the base is 16. So the way in decimal the base is 10, in binary the base is 2. Over here the base is 16. So we have 0 to 15 numbers. The total is 16 characters. 0 is 0, 1 is 1, so up to 9 there is no change. But from 10 onwards, 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Let's calculate that what would be the hexadecimal value of 75. So this is 128, this is 64, that's 32, 16, 8, 4, 2 and 1. So we won't take 128, we shall take 64, will not take 32, will not take 16. 8 is good, 64 plus 8 is 72. We don't take 4, we'll take 1. So that comes to, this is 2, this is 1, so total is 75. So over here, first 4 characters, they would be 0, 1, 0, 0, and this portion would be 1, 0, 1, 1. So this is 1, 2, 4, so this would be value 4, and the second part, this is 8, 2, 1, that's 11, and we know that 11 is B, so 75 is 4B. But we write over here as 0x because 0x is hexadecimal identifier, right? This is hexadecimal identifier. Right. What was the need of IPv6 when IPv4 was already there working fine? It's the incredible growth of the internet for a fairly long time that created a big problem for public IPv4 address. So in fact, IPv4 addresses are getting exhausted. Uneven distribution of IPv4 address is also one of the cause of IPv4 exhaustion. This is network address translation. In network address translation, it is this router on which we shall be configuring network address translation, or the net router. It will be mapping the two networks. It will map two networks. This is network 1 and this is network 2. Mapping of two networks is called as the network address translation. Now we can use it something like this, that over here this is our public network. Public network means this is our internet, and that's our private network. So we can actually map these two networks so that all the PCs which are over here, they can enjoy the internet, and you don't have to buy a public IP address for each one of them. This is exactly like wireless router, which is given by your service provider, and every member of the family is connecting their cell phones, iPads, laptops with that Wi-Fi connection, but actually there is just one internet connection. This is nothing but network address translation. But why it is mentioned that it is hindrance to growth? The reason behind it is that the devices which are onto the private network, they are actually hidden from the external world. Yes, they are actually hidden from the external world. Now you know more and more devices are coming up, and those devices, they really require public IP address. The reason is that they will be getting their updates, they'll be getting their troubleshooting services, etc. by a direct live IP address, live or public IP address. So when that is the case, you'll require more and more number of public IP addresses, right? In case of IPv6, it is 128-bit. How much is 128 bits? It is 3.4 into 10 raised to 38. This equals to about 340 undecillion, right? Bit uncommon word to hear, but this is 340 undecillion, and this number is large enough to handle current internet growth. Now this is a comparison between IPv4 and v6. IPv4 has got 32-bit IP address, while in case of IPv6 it is 128 bits. This is important point. IPv4 has got a larger header, while in case of IPv6 it is a smaller header, and that's why it is faster. In case of v4, it uses ARP, Address Resolution Protocol, a protocol which is used to identify the MAC address of the neighbor when we have got the IP address. So there are two processes, IP request and IP reply. While in case of IPv6, in case of IPv6 it is neighbor discovery protocol, and this is similar to ARP, and it has got router solicitation, router acknowledgement, neighbor solicitation, neighbor acknowledgement, and redirect. These are the processes. Rest of them is quite easy. ICMP is ICMP version 6. So rest are all routing protocols. OSPF, Open Shortest Path First, that has become OSPF version 3. This is RIP, Distance Vector Protocol, that has become RIP-NG, next generation. This is EIGRP, and it has become EIGRP version 6. And BGP, Border Gateway Protocol. And over here it is multi-protocol border gateway protocol. So these are some of the differences between IPv4 and v6. Now 4 bits, that is nibble, right? 4 bits, and we know that bit is the binary digit, smallest unit. So 4 bits are collectively called as nibble, and 4 nibbles they are collectively called as the quibble. So in other words, in quibble there would be 16 bits, right? 4 each. IPv6, which is 128 bits, it is with 8 quibbles. So as we saw it over here, 16 bits into 8, because 8 quibbles, that equals to 128. And colon would be as a separator. The way in IPv4 we were having like say 172.16.10.1, so that 1. Over here it will be the colon as a separator. So we have got 1, 2, 3, 4, 5, 6, 7, 8. So we have got 8 quibbles, or they can also be called as the group. So it is group 1, group 2, group 3 up to group 8. Now there are 2 important rules which we must know. Rule number 1, inside each quartet of 4 hex digits, remove the leading 0. Now what leading 0 is? The 0 which is on the left side of the quartet. So you can remove zeros in the 3 positions on the left. So it means 0, 0, 0, 0, that can be written as just a 0. These 3 zeros, they can be removed. These 2 zeros, they can be removed. This 1 0 can be removed. This leads to the final answer ABCD 234 EF0A 781111. This is 0, 3333 and 4. Right? Quite easy. Drop the leading zeros. That's the rule number 2. Any string of 2 or more consecutive quartets of all hex zeros, that can be replaced as double colon, and it can be used only once. What exactly it tells? It tells that see, all these hex numbers, they are 0. Correct? All of them. And they are consecutive. So they are more than 2. 2 or more than 2. So all of them, they can be replaced by double colon. So you'll say here also, yes, but it tells that it can be used only once. So following the rule number 1, we can just convert them to 0. Right? So it can be written as ABCD colon 1111 0 colon 0 colon 4321. So in this case we have abbreviated this first part as double colon. But it won't be incorrect if you would like to abbreviate this part. So in that case, that's what has been done over here, and that's what has been done over here. So if you do this, that is if you abbreviate the second part, so then rest of the zeros over here, they should be written like this only, right? So that's the rule number 2. Yes, it would be completely incorrect if you try to write down it this fashion. This is incorrect because you cannot use this rule twice. This rule can be used once only. Once only. Because if you do this, so now see 1, 2, 3, that means there are 3 groups. So 5 groups are missing. That means these 5 groups, they are all zeros. So how will you decipher? It could be like 3 over here and 2 over here, or it could be 2 over here and 3 over here. There is confusion. So that's the reason it can be used only ones. Now these are the big boss or the authorities in assigning IPv6 address. IANA, it is the highest authority, Internet Assigned Number Authority. IANA would actually give IPv6 addresses to RIRs, Regional Internet Registry. These regional internet registries, there are 5, and these 5 are distributed across the whole earth. So that means they are as per continent. As per continent, they are spread across. Now they will be giving IP address to service providers, internet service provider. Service provider will give it to various companies, and those companies will give IP address to end users. Now these RIRs, Regional Internet Registries. One is APNIC, Asia Pacific Network Information Center, that is for Asia Pacific. This is AFRINIC, that is Africa and portions of Indian Ocean. Then we have got ARIN. This ARIN is for USA, Canada and Caribbean Islands. Then for Latin America there is a separate one, it's called as the LACNIC. And finally the RIPE, which is for Europe and some Middle East countries. The type of IPv6. If you understand it like IPv4, it would be much easier. Now in IPv4 there were 2 types of IP address. There was public IP address and there was private IP address, right? So public IP address, that means they have got right to go on internet. They are unique in the entire world. So same way over here, some names have changed. Otherwise, see, Global Unicast. Global Unicast is identified by this number 2000::3. This 3 stands for that first 3 bits, they are fixed. How come? 1, 2, 3, 4, right? Each character is a hex character. So as such total they are 16. But we are currently dealing with only this first part 2. Its binary would be 0010. Am I right? And when we say /3, so /3 means, right, the cut is over here. These first 3 bits, they are fixed, they cannot be changed. So that's the meaning over here. Now this is Global Unicast because it is always unique. That's the reason it relies on administrative process. ISPs, they assign these IP addresses and they work like public IPv4, as we discussed that they are the live IP address. So this is the prefix assignment with IANA, RIRs and ISP. Let's say IANA has got 2001::3. Now it gives to APNIC 2001::16, right? /16 means it is the group 1 and group 2. So they both are given to APNIC. APNIC would divide it further between ISP1 and ISP2. Let's say this 2001 is fixed, but it gives ABC to one ISP and DB8 to another ISP, right? And it fixes this much. So this is 16, this is 16, becomes 32. So becomes 32. When it goes to companies, company 1, company 2, company 3, if you see this first portion 2001 DB8, 2000 DB8, 2000 DB8, right? They are fixed. But then they play with this third group. And that is different. And that's the reason this prefix changes. It becomes 48, right? So over here, first 48 bits are fixed. So that's how, right from IANA to RIRs to ISP to end users, IPv6 is distributed. Now in Global Unicast, so this first portion, it is what is called as the global routing prefix. Then this fourth group, right? Because these are the three groups. This is the fourth group. This fourth group, it can be used for subnetting, and rest this entire piece is host. So in this case, host address would be 2001 db8:1. This much is global routing prefix. Then we have got the subnet, and finally the host. 64 tells that first 64 bits are fixed. So these are some similar examples: company 1, company 2, company 3, and because 3 groups are involved, that's why 16 into 3, that's 48. This is another second type of IPv6. This is called as the unique local unicast. Name itself is telling this is local. That means this would be sort of a private IP address, right? This is sort of private IP address. And its speciality, it starts with FC::/17. But then IANA said, no, we want to reserve this thing. We don't want to give this right now. So it has been reserved. Changed to FD, right? So in use is FD::/8, and the details of this rule has been mentioned into RFC 4193. As this is a sort of private IP address, there is no administrative process needed. You can assign it by yourself. They are definitely not unique. Works like private IPv4. And there is the same method of subnetting as we saw in Global Unicast. So in unique local unicast, address structure would be quite similar. Previously it was Global Unicast. Now this is unique local. So first is FD, because that's the identifier. This is subnet, and that's interface. The next type of IPv6 address is link local. Now this link local, it is identified by FE80. It is auto-generated. This address, it uses MAC address of the interface, and this is used for NDP, Neighbor Discovery Protocol. Link local address, the first half is fixed. This is the first half, and this first half is FE80::/64. The second part, this is the second part or the second half. So here we know that MAC address is 48-bit. We want 64. So that's why we shall be adding 16 more bits to make it 64. So these 16, they are like FFFE, right? This is FFFE because 4 bits, 4 bits, 4 bits, 4 bits, total 16 bit. And this FFFE is to be inserted in MAC address. And then we have to flip 7th bit from first group of MAC address. Now instead of theory portion, let's calculate and it will become much easier. Let's say this is our MAC address. Okay, ABCD 1234 ABCD. Excellent. Now we shall insert FFFE. So easy. So this would be the place of insertion. So it becomes ABCD:12FF:FE34:ABCD. We need to go for 7th bit over here. So A is 10, it will become 1010, and second is B is 11. Now if we calculate the 7th bit, so that's first, second, third, fourth, fifth, sixth, 7th. That's the bit which we are talking about. It is 1, so flip it to 0. Calculate what would be the value of rest. So this is 8 plus 1, 9. This leads to the final answer. So FE80:A9CD:12FF:FE34:ABCD. Right? right? So that's what is called as the link local address. The next type of IPv6 is multicast. It's identified by FF. So here are various types of IPv6 multicast addresses with IPv4. This is for IPv6 and this is for IPv4 multicast addresses and their purpose. So say for example FF02::2 was 224.0.0.2 in IPv4 and it was for all routers. Let's say if we are talking about EIGRP, that means anything sent on FF02::A in IPv6. In IPv4 it was 224.0.0.10. Now we know that 10 is A. So anything sent on this can be heard by only those routers who are running EIGRP. So that's the meaning of multicast. Multicast is one to a specific group, right? One to specific group. Now in multicast there are some scopes also. Scope means range. Till what point this multicast should act. So let's say when we talk about FF01, so it is just up to interface. That means packet will remain in device only. Let's say when it is FF02, so it is link local. That means router won't forward the packet. It will remain till it reaches the router, right? So that way FF0508. Next is Anycast. Now this Anycast is a concept. Very interesting. Anycast is one to nearest. This is the point which is so important, that Anycast is not a specific address. No specific IP address is Anycast. In fact, any address can become Anycast. It's like a service. So you have to really declare that specific IP address as Anycast. So say IPv6 address, you are giving the IP address, IPv6 address to some port, and you give command IPv6 address, you give that specific IP address, and in the end you write Anycast. That's it. These are some special IPv6 addresses like unspecified address ::/128. This is equivalent to 0.0.0.0/32. Let's say when we talk about default routing, right, we use 0000/0. Over here it is ::/0. Loopback address, which is used for checking our own interface. In IPv4 it was 127.0.0.1/8. While over here loopback address is ::1/128. Worth remembering. Now we go on for real implementation of IPv6. Now in IPv6 there are 4 different methods of giving IP address. One is static. The second one is called as the DHCP, Dynamic Host Configuration Protocol. The third type, it is called as the EUI64. The insertion of FFFE into the MAC address plus 7th bit flip. And the last one is called as the slack. Let's implement it practically. We'll take one switch and we'll take one router and we'll just connect it. And over here we'll be giving static IP address. Now let's start with our first part, that is static IPv6 configuration. So in this, what we shall be doing, to gig 0x0 port of this router 1, we'll give the IP address 2001 colon db8 colon 1 colon 1/64. Some important things. For every router, in config mode, you need to give this command IPv6 unicast -routing. Then and then IPv6 functionality would start. And then in interface mode, yes, you'll give IPv6 address and then the specific address along with its prefix. So let's do it. So that's our router. We say no. Enable mode, we go to config mode. In config mode, we just give the name of this router R1. We give IPv6 unicast -routing. And then we go to interface gig 0/0 and we give IPv6 address, and this is 2001 colon db8 colon 1 colon colon 1/64. Enter. We just open the port. We give by no shut. Done. Exit. Control Z, and we give show IPv6 interface brief. And here it is. Here is 2001 db8 colon 1 colon colon 1. That's the IP address which was defined statically. Let's see the second part. This is via DHCP. So here to this switch will connect one server. This would be our DHCP v6 server. And to check, we'll connect two nodes, N1 and 2. We'll create a range over here, or the scope, or the pool, and we'll make it like say this 2001 colon db8 colon let's say 2 colon colon /64. So this means that both node 1 and node 2, they would pick up the IP address. First half would remain the same. It would be the random number in the second half of the IP address. Let's check it. So adding two nodes. We add one server. Let's connect them. That's our server. We go to services, DHCP v6. Right now these services are off. So we turn it on. We create a pool. Let's say pool's name v6 pool. And to this we are adding IP prefix. So 2001 colon db8 colon 2, right, colon colon, and then 64. This is indicative of that first 64 bits will be fixed. So we close this and we come to its interface part. Interface. So we need to give some IP address to this, and it has to be static. Let's say for this laptop, go to config. That's the fast Ethernet. That's the port which is connected. Right now it is static, so nothing is shown. The moment we are doing it automatic, here it is 2001 db10. This first part, as I said, it is fixed. Rest 290:CFF:FE94:6ABB, that is what it has taken by itself. Let's see that thing onto the second laptop. Fast Ethernet, this is static, go to automatic. Here it is. 2001 DB810, that much is fixed, and 2D058FF. Rest is random. So this is how you give IP address with the help of DHCP server to the nodes. Let's say this is router 2 and you want to give IP address to it via DHCP. So the command is, in interface mode you will give IPv6 address DHCP. That's it, right? So this was the second part. First one was static configuration and the second one is via DHCP. Now the third one is what is called as the EUI64. So let's see that. Now this EUI64 or the extended unique identifier. It works on two principles. 1, 2. Insert FFFE in MAC address. And second, flip 7th bit. Right? Let's see. Let's put one more router. Right. And to this fresh router, they go to this IPv6 Unicast dash routing. We go to interface gig 0x0 and we give IPv6 address, and this time 2001:DB8 and 3:/64 space and EUI-64 and enter. Now let's check it if we are getting the same correct IP address. 2001:DB8:3:0:230E3FF FED83801. So this is how this EUI-64 works. But let's check it. Come over here. That's the MAC address. See, that's the MAC address. So we gave 2001:DB8:3: and then the slash. So over here, that's the MAC address, right? To this MAC address, we have to insert FFFE. Now we'll be inserting this FFFE over here. So the new value would become 0030:FE://DB:380:1. So now this is a 64-bit system. Only one thing which is left out is flip the second bit. So this is 0, right? So 1, 2, 3, 4, all are 0. We have to flip this bit, so it becomes 2. So it will be 0230:A3FF and then rest is all same, FEDB:3801. So that's the flipped 7th bit. And when we combine both of them, so this is 2001 DB83 followed by 0230, right? So are we getting this address? Are we getting our address 2001 DB830? Then this is the leading 0, so eliminated. So 230 correct, colon A3FF correct, FEDB correct, and 3801 correct. So this is how you give EUI64. And the fourth way to give IPv6 address is slack, stateless address auto configuration. Now what exactly this is? This is our router 1. On the gig 0x0 port, we shall give a static IP address. Let's say this is 4th. So we give, say, 2001 colon DB8 colon 4 colon 1/64, right? So focus on this. Now what would happen when you want to give IP address to this router, but you want it in like a slack style? Okay, so that's gig 0x0 port of router 2, and we'll give the command IPv6 address auto configure. This would be the command IP address auto configure, and then what we would see is it would pick up the network portion from here. So first 64 bits, they would be calculated from the gateway, and the second portion would be calculated by the principle of EUI64. Now you know it, right? So let's do it, and then we calculate, and then we'll check whether it is getting the same IPv6 address or not. So we go to 2911, the router 1, right, and we just give enable config D and host R1, and we activate IPv6 unicast routing. We go to interface gig 0x0, and we give IP address IPv6 address 2001 colon DB8 colon 4 colon 1/64, right? So this is a static address. We just give no shut and exit, Control Z. Alright, we just check show IPv6 interface brief, and yes, it has been given and it is up. Okay, interesting would be the second. We just fast forward it. Interesting would be this second router, right? So for the second router, once again on CLI, we go for this no, and we enable it. We give config D, host name R2, and we activate v6 system. So IPv6 unicast routing, we go to gig port, gig 0x0, and we just give IPv6 address and auto configure. That's it. Exit, Control Z. We missed one thing. Yeah. Config T, interface gig 0x0. We need to open the port, no shut. So now the port is open. We just exit, Control Z. Show IPv6 interface brief. Well, it has not yet come. It is in the process of calculation. Let's fast forward it. Okay, we check again. Here it is. Okay. Now, what we are doing is we go to config gig 0x0, and here is the MAC address. So let's calculate that what should be the IP address obtained when this is our MAC address. Now from this MAC address, using the principle of EUI64, we know that this 000B, right? So this second zero, so that will become 2 because 1, 2, 3, 4. This is 0000. This bit would be flipped, it will become 1. It will be 0, 2, 0, B, colon, and then B, E, FF would be inserted here, and FE 51 because FF, FE would be inserted, and 8A01. And regarding this first part, that would be picked up from the R1, so it will become 2001 DB8 colon 4 colon 0. So this should be the address obtained on gig 0x0 port. Let's check. So we go to CLI and show IPv6 interface brief, and here is it. 2001 DB8 4 0 020B BEFF FE51 and 8A01, right? This is the 0 which can be dropped, right? It can be dropped because it is a leading 0. So this was what's called as the slack. Now for today's answer. This is USB 2 and it transfers at the speed of 480 Mbps. When it is written SS, you can say SS is like super speed. So this would be USB 3.0 and with the transfer speed of Gbps. This is still higher, and this 10 indicates that this works on 10 Mbps. This symbol of battery, it suggests that this port will give power to connected device. So now it's much easier, right? When it gives power to connected device. So over here, this is USB 2, this is USB 3, and that's USB 3.1. So it gives power to charge the connected device. This section, this particular symbol indicates alternate display. So this is a port which is USB 3.1. It works on 10 Gbps and it would give an alternate display. USB 3.1, it is with alternate display. It works on 10 Gbps and it gives power. Now if you see a white symbol, it is called as Thunderbolt port. So in Thunderbolt port, and finally, if you see a black lightning type of symbol, this is for fast charger. So these are the symbols and their meanings. That's it for this session, and do write your queries and comments in the comment section. And in case if you are not subscribed, kindly do so and press the bell button for getting immediate updates. Thank you so much and see you very soon.